Hello guys, welcome back to another video. In this video, this is a very important video because we're going to be looking at a question that basically summarizes all the proteolytic cleavage questions. So if you're able to answer this kind of questions, you'll be able to answer majority of the proteolytic cleavage questions. Now before I begin, I just want to remind everyone that we're near 100 subscribers and thank you everyone for that. And I'm having a quiz for the 100 subscribers where there will also be a prize money. Check the link in the description below for more information. So now getting on with the question. So this is a GATE biotechnology question for 2 marker and it has negative marks associated with it. So what the question says is that analysis of a hexapeptide with a enzymatic cleavage gives the following results. The amino acid composition is 2R, that is 2-arginine, alanine, valine, serine and tyrosine. So this is the amino acid composition and there are 6 amino acids, 1, 2, 3, 4 and 5, 6, 2 of them. Then second one is they did trypsin digestion. Trypsin digestion gave 2 fragments, that is one of the fragments had a composition of RAV, meaning it came in either order, it can be AVR and all, but the composition had RAV and the other one had RSY as the other fragment. Then chymotrypsin gave 2 fragments again, ARVY and RNS. And finally carboxypeptidase A gave no product. Now to answer this kind of question, you have to know what the cleavage sites for these different enzymatic enzymes are. So if you look at from my previous video, which I'll link over here in the iCard, you'll remember that trypsin digestion occurs in the carboxyl terminal of lysine and arginine. So lysine and arginine. Only if the carboxyl terminal has lysine or arginine, then only would the cleavage occur. Followed by chymotrypsin. Chymotrypsin will only cleave if there is an aromatic group. What are the aromatic groups? It is phenylalanine, tryptophan and tyrosine. If the carboxyl terminal has these 3, then only will we be getting fragments occurring. And finally, we have carboxypeptidase A. Now, there's something important to know. Carboxypeptidase, I'll just carboxypeptidase, and trypsin and chymotrypsin and all the other ones which have all the other enzymes like cyanogen bromide and all, that's a chemical reagent. What happens for them is they are endopeptidase. There is something known as carboxypeptidase. Carboxypeptidase, suppose if I have a fragment like threonine, again 2 threonines, arginine, lysine and valine. Suppose if I have something like this, carboxypeptidase are the enzymes that will cleave the carboxyl terminal of the amino acid. So if it's any amino acid, the carboxyl terminal, that is the C terminal, will get removed. So this will effectively become TTR L and then plus V. So it will be able to cleave out the carboxyl terminal. If I say aminopeptidase are those enzymes that will cleave the amino terminal. So if you do cleavage with this, it will become T plus TRLV. So this is aminopeptidase, and this is carboxypeptidase. Alright. Remember, endopeptidase can only cleave if the product yields a dipeptide. A carboxypeptidase or aminopeptidase will only cleave if the product is a single amino acid from the terminal group. So you have to know that. Now, another subset is carboxypeptidase can be divided into carboxypeptidase can be divided into few more subgroups. There is something known as carboxypeptidase A, carboxypeptidase B and carboxypeptidase C. Alright, carboxypeptidase A will only cleave, it will cleave if any sequence except EXPT if the N-terminal residues are proline, lysine and arginine. So if the ending is proline, lysine or arginine, the cleavage won't occur and you won't be getting any product. So you can see the relation happening here. That's second one. Carboxypeptidase B will only cleave. It will only cleave if the N-terminal is lysine or arginine. So if you have lysine or arginine in the carboxypeptide in this N-terminal, only then would it be cleaving. And carboxypeptidase C will cleave all. It doesn't matter. And aminopeptidase will usually cleave everything. So now using this, we have to start going. So remember, carboxypeptidase A means no product. What does that mean? No product means carboxypeptidase, the N terminal should be having something like a proline, lysine or arginine. So have proline, lysine or arginine as C terminal. Okay, so now we have this kind of information. Now first, I'll just flip the page. So now first we have to do, first analysis we have to do. Trypsin, it's a trypsin cleavage, give two fragments, RAV and RSY. Now what does that mean? One of the fragment, one is that it can be RAV or VAR or this thing, it can be RAV, VAR, AVR and so on, the different permutation combinations. Now you have to remember, if the cleavage occurs, see, there are two R residues. So if one cleavage, so if you get two fragments, this implies there is only one cleavage site. Why does it make sense? Suppose if I have some residues like this and I have R and again some residues like this, then if I cleave here, only will I be getting two fragments, correct? Two fragments compared to, or if I have again something like some two of them R and then one R again and two. Imagine this is the case. Since I have two cleavage sites, the cleavage will occur in these two sites, giving how much? We'll get three fragments. So number of fragments is always equal to n minus 1. What is n? Where n is the number of cleavage sites. This is usually the rule that is being followed by, if you look at the general principle, this is what actually happens. So number of fragments is always equal to number of cleavage sites minus 1. So using that, if I'm finding two fragments, so one thing is that there is only one internal cleavage site. So what does that mean? If that is the case, then these two fragments, there are only two possibilities. Either we have one fragment is that it will be VAR. This is the amino terminal with VAR plus anything, or we'll have some random thing with the next one having YS and R. Either this has to be plus this. Either this has to be the case or this has to be the case. Now, this gate question was actually quite simple for people who already knew that. If you knew that AVR or VAR is a combination that has to happen, where this R group would be in the middle, if you scan this, only the option B has this kind of configuration. AVR, so cleavage will occur here, we'll get the two fragments, AVR and RSY. It doesn't matter what, because you already found out from AVR, this is the case. No other group. See, if this is the internal, look at this option, if this is the internal amino acid cleavage site, the cleavage will occur here with trypsin, giving two fragments at RSYR and VA. It won't occur. No. This one, okay, we made it true. Again, VAR here, but the internal group is over here. Alright, but since the internal group, there are two fragments when you do trypsin degradation, SR and YVAR. So again, this can't be true. Then if you look at this, there is, as I said, on the two groups here, if it cuts over here, it's SVR and RYA, nothing. So in all these cases, only B is true. But for the sake of answering, I will continue doing for the other ones. So next is chymotrypsin cleavage, give two fragments. Remember, chymotrypsin will only cleave if F, W and Y. That is phenol, tryptophan, tyrosine. If you look here, tyrosine is again there. So this fragment is actually given in the proper orientation. Suppose it doesn't matter, it can be VAR, RVA, AVY, anything. But Y should be the last amino acid. So if I do for the chymotrypsin degradation, it should be AVRY. Or it can be any kind of combination where this is the amino terminal, NS3, and Y should be the internal group and followed by two more. So it doesn't matter what these are, you just have to realize Y should be the center one. So if you look at all of them, again, if this is Y is the cleavage, you'll get two kind of this. Only for here, if carboxypeptidase cleaves, this is carboxypeptidase. Carboxypeptidase will give you, if it will again cleave on the carboxyl side, it will give YRAV and another group of S and R. Alright, so in other groups, nothing actually happens like that. See, over here, if you click, we'll get SRY and VAR. Doesn't happen. So this is the reason why nothing happens. And finally, we have carboxypeptidase A. No product if the N terminal is P, K, and R. So what does that mean? If I have alanine as my N terminal, I will be getting some kind of product. Since this has N terminal of R, it won't be giving any product. Okay, then this also won't be giving any product. This will give a product. So because these are giving product, automatically they get cancelled out. This also will be giving a product. This won't be giving product, but then like I said, it didn't find out the other trypsin and chymotrypsin, it failed to do. So that is the reason the correct answer has to be, without a doubt, it has to be AVR, and YSR. YSR. See, because there's a carboxyl terminal of R, the C is satisfied. Because cleavage occurs over here, B is satisfied, and because cleavage occurs over here, A is satisfied. Trypsin, chymotrypsin, and carboxypeptidase. So I hope you enjoyed this video. This is basically on how you can solve questions based on enzymatic cleavage. If you're able to understand these simple concepts, you can answer a majority or usually 99% of all cleavage based questions coming in any kind of competitive exam. I've noticed it's come in CSR exams, it's come in interview questions also, and it'll usually come up in gate questions also. So I hope you're able to understand and enjoy this question. You can please rewind a few times to remember the different cleavage sites and how you can go about it. And reminder to everyone that there's a quiz happening, and it's a quite simple quiz with a prize money for the winner, and you can register with the description. Just look at the description for more follow-up on it. So thank you for watching. I'll see you guys in the next video. Bye.